Okay, so this question says gravel is being dumped from a conveyor belt at a rate of 20 cubic feet per minute. It forms a pile in the shape of a right circular cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 11 feet high? Okay, what are they talking about? Well, we've got this cone. Let me see if I can. Oh, like that. So we got this conveyor belt. The belt comes out here from the wall, and gravel is on it. And gravel is dumping down and forming this big pile. Okay, and it says, and so this is the radius. Oh, wait, did it say? Whose base diameter and height are always equal. Okay, diameter and height are always equal. Okay, mine doesn't totally look like it, but and maybe I could do that a little better. Diameter and height are always equal. Okay, let me try. Let me try a little bit better. It's going to be a little wider. Kind of like that. All right, that's a little better. So this is the radius. This is the height. Okay, so and it says diameter equal height. Just the way the gravel falls, right? Base diameter and height, they're always equal. Diameter is 2r, right? Diameter is all the way across the circle. Diameter means, all the way across. Radius is half. So diameter is two radiuses equal the height. Okay. Um, and then we have the volume statement for the volume of a right circular cylinder. This is called this right circular cone, I mean. Right circular cone. There's the volume that they gave us. Okay. And now, so the first thing you need to remember these steps. Step one, identify rate variables. Like, what are they asking for? What are they giving us? Well, it says 20 cubic feet per minute. Cubic feet is volume. That's dV dt is plus 20, meaning the volume, the total amount of gravel in the pile is increasing by 20 cubic feet per minute. Cubic feet is volume. You guys know about cubic feet? So a cubic foot, it's a foot by foot, oops, cube. So that's 1 cubic foot. It's a cube. It's foot by foot by foot. 1 foot by 1 foot by 1 foot. So it's volume. My point is it's three-dimensional. It has length, width, and height. It's volume. So that's how I knew right away this is volume by units. I survived physics by looking close at units. Cubic feet, that's volume. It's not area. Volume is three-dimensional, right? That's volume. Okay. And the question is, how fast is the height of the pile increasing? So they want to know what is dH dt, right? When the pile is 11 feet high. So H is 11. Okay. Well, okay. So step number one, identify the rate variables. Got it. Step number two, write an equation with only those letters. And then numbers are fine. Only those letters. So right now I've got V, R, and H. Pi, that's a number really, one-third's a number. So V, R, and H. Is that what I want? Well, I want V, I want H, but I don't want R. So I got to get rid of R. How can I do that? All right here. Divide by 2, divide by 2. Boom. R is zero point 0.5 or a half H. So grab that and put it in for R. I'm using R I'm using 2R equals H. Then I'm dividing by 2 on both sides. And so R is 0.5H. Plug it in. Why? Because I want only those are what letters? H and V. Only the rate letters. That's why it's so important on step one to identify the rate letters. So then we get V equals 1/3 pi. And then what is R? R we now know is 0.5H, isn't it? R is 0.5H. So now let's clean that up a little bit. We get 1/3 pi. Square that, you're going to get 0.25 H squared times H. And so put that together. 1/3 pi. Oops, getting a little scribbly there. 1/3 pi times 0.25 H cubed, right? So now we've done step two. We have an equation that only has V and H and then a bunch of numbers. V and H are my rate variables. So you step one, you identify your rate variables, the ones they mentioned in the problem. They talked about the rate, dV dt, and they asked for how fast is the height of the pile increasing, dH dt. So you got to get an equation involving only those two letters. Got it. Step three, d dt both sides. Take the derivative with respect to time, d dt. Same thing here, d dt. Derivative with respect to time. So this is going to be dV dt equals, now what's going to happen on the other side? Well, the 1/3 pi 0.25, that's just numbers. And I can take the derivative of the h, bring down the 3, h squared dh dt. All right. Now, step 4, plug in. Plug everything in. We don't plug in until after the derivative, notice. Okay. So now they told us that right here, dv dt is 20. So this is 20. And 2 times 3. H, I think I know H right there is, H is 11. So 11 squared. And dH dt, oh, that's what I'm trying to find. So I'll just leave that as dH dt. That's what I'd like to find. Okay, I'm going to solve for dH dt. I'm going to divide, boom, boom, on both sides. So 1/3 pi 0.25311 squared. And that's just all 1/3 pi 0.25311 squared. So dHdt is alone. Let's go to Desmos and hit the buttons on the calculator. We're typing in all of this. All right, let's go to Desmos. 20 over 1/3 pi 0.253, 1/3 pi 0.253, 1/3 pi 0.25 times 3. What else we got? 1/3 pi 0.253, 11 squared. Boom, we're there. Times 11 squared. There we go. 0.21045. 0.21045. 0.21045. It's positive. 0.21045. 0.21045. And that is positive. That means the height is going up 0.21 feet every minute. The height of that pile is going up 0.21 feet every minute. Isn't that interesting? We can figure out based on how fast the gravel is being dumped into the pile and how the pile grows with a height equal to the diameter, that if you dump gravel at that rate, at the rate of whatever it was, 20 cubic feet per minute from the conveyor belt, that the height will grow by 0.21 feet every minute. And those are our units on that one. Yeah, because it was per minute. And so there we go.